Right then, cloud gurus. Horizontal pod autoscaler. We know I love the sound of it, but it's actually a pretty descriptive name. We're scaling pods. And I know it sounds obvious, but I want to be super clear about this. HPAs are all about pods. Scaling pods, watching pod metrics, you name it, it's all about the pods. And I stress that because we're going to be talking about the cluster autoscaler in a minute, which is not about pods, that's about nodes. So for now, we're all about the pods. Anyway, horizontal, so more of the same pod, scaling out rather than up, if you will. So demand goes up, we scale out, we throw more of the same pods at it. And then autoscaler, I mean, sure it needs some initial setup, but once that's done, everything's automatic. Demand goes through the roof at 4:20 in the morning, you can sleep like a baby while Kubernetes does all the work. Marvelous. So it goes like this. You define the HPA like any other resource in the API. You tell it which deployment to work on, so it's a one-to-one relationship, yeah, 1 HPA per deployment. You set a target utilization, and this one's for the V1 API, yeah, which only supports CPU utilization. And what we're saying is, do us a favor please, Kubernetes. Try and keep things so that our pods are using less than 50% of their requested CPU. Cheers. Now, what this means is that you have to create your pods with resource requests. And this will be the same for the cluster autoscaler in a minute. And to be fair, it's the grown-up way of doing things. Create your pods with resource requests. So, this one here, which we'll see in a minute, this is asking for 20% of a CPU. I like specifying it like this, but other people like the more precise way of saying 200 millicores. But it's basically this. One virtual CPU on your cloud platform equals one CPU to Kubernetes. So 1 or 100% here, or 1,000 millicores, that's a full CPU. 50% or 500 millicores, that's half. You get the picture. So for us here, 0.2 is the same as saying 200 millicores. It's 20% of a CPU, yeah? Okay, if we attach it to this deployment and then we throw some work at it, and it uses more than 10% of a CPU, 100 millicores or whatever, that's going to breach this rule here that's saying keep it below 50% of what we've asked for, and it'll trigger a new pod. So, a pod asking for 20% of a CPU. An HPA object keeping an eye on it by waking up every 30 seconds by default and checking it's not using more than 10% of a CPU. If it is, spin up a new pod. Good stuff. And remember, this gets even better with the stuff that's coming in the V2 API, which out of the box will support memory as well. But with the custom metrics API, I'm telling you, all things are possible, which will be a huge improvement. Oh, and we set some limits for the scaling. So here we're saying, don't ever take the number of pods in the deployment below 1 and never go above 10. And the way that it works kind of behind the scenes is that the HPA modifies the scale sub-resource of this deployment here, so effectively incrementing the spec.replicas field, and then the deployment itself with its associated replica sets makes the scaling actually happen. So as you'd expect, the HPA itself, it's got no clue about actually how to do the scaling. It just knows when scaling needs to happen, and it tells the deployment to do it. And then the deployment tells the replica set, and it's business as usual. Okay, I'm sure I don't need to, but I'll say it anyway, right? You deploy and manage it with kubectl and hopefully declaratively. Now, to stop things scaling up and down like crazy, yo-yoing and all that, there's built-in safeguards that say things like, wait 5 minutes between downscaling operations and wait 3 minutes between upscaling. And I think the last one for me to say before we look at it in action is that when doing scaling operations, load and redundancy are taken into account, which they would be, right? I mean, it's not like the HPA itself is doing the scheduling. It's not. All the HPA cares about is deciding when scaling operations need to happen. All the mechanics of how it happens, yeah, like we've said, that's handled by the relevant specialized parts of the control plane. So net, on the redundancy front, the regular scheduler is going to make sure that the new pods get evenly balanced on the cluster. And that's the theory. Let's have a look at it.